So a sequence, you were saying, is basically a list of numbers. Now, you may be thinking, a list of numbers, where have I heard these guys say that before? Sets. But sets also come in very important somewhere in a function. Sets are literally how we define functions. What functions do is they take sets and they mount and they change it up. So here's what I wanted to say about this whole thing. So we have a sequence that is basically a set of numbers. Now, the reason why I was saying that it has to have some order, because every sequence can be written as a function of n.
That's not true.
Is that not true? I thought that was true. No. Every sequence cannot be written as a function of the number at the element of the sequence?
No, it's not true. Like, just a general sequence can literally be a list of just random numbers.
Just like a set, basically. Just a set.
Yeah, literally.
Okay.
But, just like functions. Functions don't have to be nice. They just have to mount
No, but they have some, but it's a function of x, is what I'm trying to say. So there's some relationship between the variables.
No, but Ray, think about it.
Yeah.
Think about it for 1 second. Remember how you can define a function as, like, it's equal to 1 on the rational numbers, equal to 0. Like, you can define a function with words. You can also define a function by literally one by one associating every real number with another real number. And that will also be a function. The same thing with sequences. You can just associate every natural number to another number randomly, and it'll still count as a sequence.
Okay.
It doesn't have to follow any pattern. But, of course, those aren't really useful, right? So the sequences that we look at are sequences like, that are associated to functions or that are defined like the Fibonacci sequence, things like that.
But, well, before we really get, because we've defined kind of, a sequence is a set of numbers, but let's try to maybe differentiate a little bit between the sequence and the function, right? Because the function because again, when we just say set of numbers, it can be taken as but it's not exactly, right? So like the main difference, is that a function takes in a variable and it spits out something. So it has a relationship between x and y, which are our two variables, right? And it has multiple points. In this case, I'm just talking about a 2D function, so just one input, one output, very simple, right? Sorry?
That's a one-dimensional.
Well, yeah, one, but I'm trying to say like graph. Yeah, but that's what I'm saying. So like one input, one output kind of function. So it's super simple and it's kind of like pairs almost, right? So it's like one number associated with something else. And in a sequence, again, we're talking about the interesting ones. So the ones that can actually be written as of. So when we say that the main difference is what. So, okay, let me try. I'm just trying to think of it and a nice way to say it. We say a function of x, and x and y are related. When we do a sequence, it's a function of the element. How am I trying to say this? Like of where it is in the sequence, right? So every sequence, let's say it's 1 to 10, every element of that sequence will have a number. So 2 is the second term of the sequence. 8 is the 8th term of the sequence. So that number that I'm referring to is n. Right? So 7 is the 7th term. 10 is the 10th term of the sequence.
So like the cardinality, or is that what it's called?
Is that what it's called? I have forgotten.
Like the order of which.
Yeah, ordered, obvious. But I'm saying that n, again, I'm kind of forgetting what that, like a nice way to say it if it's already defined technically.
Oh, the indice?
Index. The index of the sequence would be a nice way to define it. Yes. So the position of that
but
element.
I don't know why you're saying it so complicated though.
The reason I think I did overcomplicate it, but the point that I was trying to make is that a function is a function of the variable, while a sequence is a function of the index. So that's just that differentiation that I wanted to put out, because it's very similar, right? Because if you think about it, a sequence and a function are basically the same thing, because you can write a formula, like an equation for a sequence, right? For the nth term of the sequence. And in the same way, you can write a formula for a function. So a y term that correlates with some given x. So I just wanted to point out the fact that they're so similar, the function and the sequence, but they're also different because technically they are depending on different values, right? I just want to kind of bring that similarity and that distinguishing between the sequence and the function.
No, I don't mean to like rag on your explanation, but I really don't like how you said it.
You don't like the function indices definition? Let me hear how you would do it.
Well, how I would say, I would
Yeah.
be like, okay, well, a function, just like a simple one-dimensional function is defined over the real numbers, and a sequence is defined over the natural numbers. That's it. So if you graph a function, it's like a nice function, it's smooth and whatever. And when you graph a sequence, it's just like dots that appear over the
Yeah, but you can
numbers.
also have a discrete function. You can also have a piecewise function, stuff like that. Like,
yeah, I guess so. Depending on your domain. And
so
all
that's
that
what I'm
stuff.
saying. So I'm just trying to, because you're talking about the general function definition. So yeah, obviously they're different because a function can be continuous, right? And a sequence simply inherently cannot. So there's that number one difference, of course, between them. But I'm talking about a discrete function versus something like a discrete. So like I'm just trying to, again, pull out the similarities and the differences, right? Just to understand, well, what is the relationship between these two things?